and then we're going to simplify it. We're going to learn 3 basic rules of how to apply the process of getting the function of the derivative to the original function. Okay? So I'm just going to create some arbitrary curve here. I'm going to put this point over here, and this point over here. And if we found the slope between these 2 points, I'm going to call this the x mod, and I'll call this x1. And so this would be the y, the output of the function at x nod, and this would be the y, the output of the function at x1. Okay, and so when we calculate the slope, that would be that. Okay, so the slope, which is what we want, what is the function that creates the slope of all the tangent lines, involves this process. Okay, so we would subtract the y's, top minus bottom, and subtract the x's, top minus bottom. Now I'm going to simplify the denominator, because right now it's a whole lot of variables. I'm going to call this h, this width. Okay, and then I'm going to call where we start x. And the next point I'll say, well, from this x, we're going to add h. So I'm going to change this. I'm going to use these 2 and put h on the bottom. And this is just for simplification. So I set it up formally first, but now we actually need to do some math. So let's simplify the math we have to do. That's why I did that. Okay, so I called the distance between the 2 points on the x, h, and then I changed the x's I'm using in the functions. Here's the x we're starting with, and then the next x would be plus h more. Now here's how we do this. I'm going to eventually show you with a particular x squared, we'll set this up and actually do it. What we're going to do is we're going to gradually approach the bottom point by moving the top point down, which is going to shrink the width of the triangle on the bottom. What's going to happen to the h as we move the point down to the other point? What's going to happen to this h as we move that point down?
It's going to become 0.
Bingo. So we do this math, we simplify it, and then we replace h with 0. And that's how we create the function that will tell us the slopes of the tangent lines. So if we use a particular famous function, x squared, how would we find the slopes of the tangent lines on the parabola? So if this is our basic function, we do this, and so we're going to substitute for the x plus h in this first part, and here we'll just have the regular x squared. Okay, so then we will do this. Now again, I'm keeping it simple so you can get the idea of how it applies. This is the only time we'll do this, just so you can see where it came from. All right, so we do this binomial, multiply out. Now notice it's not x squared plus h squared. Remember, this is FOIL. X times x, 2 times xh, and then x squared, right? You're going to get 2 xh's. Okay, so you get x squared plus 2, and I'll put the h first, plus h squared minus x squared over h. Notice we're going to subtract the x squareds. And then when we simplify, this first piece, you'll just have 2x left. And then the second piece, you'll have h. And when we replace h with 0, we get 2x. That's the derivative function of the parabola. The slope of the tangent line is 2 times the x value. Now remember I pointed out that little trick that you always get doubled? That's why. Right? The linear term and the squared term is how you got those two numbers when you substitute to find the y at the vertex. That's the reason why they're doubled. Kind of cool. Now this is very formal. And we don't want to have to do this for every function. We don't have to do this with x cubed, right? We don't have to. And what if we had a polynomial? X to the fourth plus 3x squared minus 8. We don't want to be doing this. With x squared, it's not too bad because we can just multiply the binomial and then we can simplify. So what mathematicians who are smarter than us, including me, they developed rules by doing this algebraically, and that's why we have the rules I'm going to show you in a second. But first, let's see what this means. When we say 2x is the function that gives us the slope of the tangent lines, we call that the derivative of x squared. That's what we call that. Okay? How do we mathematically state that symbolically? Since the derivative of the function x squared is 2x, we say a little tick mark, the derivative of the function was 2x. This is the mathematical symbol that means that.
Mr. Napoli?
Uh-huh.
So how do we know that h equals 0? Like, where did that come from?
So remember I asked that question earlier about, when this point approaches that point, right? And that was h. What happens to the width here as the top point approaches the bottom point?
Oh, okay.
Right?
0.
Okay. Now I'm glad you asked because that's an important point to make. Okay. And again, I don't mind going over it if it helps. So thank you. Okay. So now I'm going to show you, I'm going to put the x squared graph up here. And I'm just going to sketch this. Okay. So here's our x squared graph. Okay. So here's 1. Here's 2. Well, when x is 1 on the graph, the slope of the tangent line would be 2 times 1. So this tangent line here on the graph when x is 1, that's going to have a slope of 2. Okay, so on the graph when x is 2, the slope of the tangent line that crosses the graph when x is 2 is going to be 2 times 2. So the slope of this tangent line is 4. So that's what that means. That's what the derivative means. It gives us the function of the slopes of the tangent lines to the original function. And Tuesday, I'll show you how to actually find the equations of these tangent lines. We're not going to worry about that today. Okay, so far so good? All right, so that's where this stuff comes from. And now we're going to look at the rules because this is too much work. We don't want to be having to do that all the time. There are patterns, and that's good.